So one common engineering application of differentials is approximating the errors with physical measuring devices. So we know that our measuring devices aren't always entirely accurate. Okay, so your ruler or your scale or something might be slightly off. Okay, so if x is the measured value, and then x plus delta x is the exact value, which we don't actually know, then that delta x is the error in measurement. And that's something that's important to know, because if we have some sort of error in measurement, which we are likely to, I mean, nothing's perfect. So then if we use x to go on and calculate other things, volume or area or anything like that, that's going to create an error in our y value. So the difference between our actual y value and what we came up with is called the propagated error. Okay, so it comes from an error in our measurement that's basically used to calculate something else, and we get this propagated error. Which happens, it's going to happen in the real world because no measuring device is perfect. But we need to be able to measure how much propagated error there could be to see how much impact that'll have on things. So the example I want to look at is we have a ball bearing. Okay, so ball bearings are used in lots of devices, mechanical engineering. There's a picture of this on 269 in your book. So the measured radius of the ball bearing is 0.7 inch. So we know that the radius is measured at 0.7. And the measurement is correct within 1/100th of an inch. Okay, so whatever measuring device we use, it's pretty close, it's pretty accurate, but it might have a change that's plus or minus 0.01. Okay, it might be slightly off. Okay, so now we want to talk about the volume of this ball bearing. Okay, and we want to know the propagated error in the volume. So the volume of a sphere is 4/3 pi r cubed. We're going to take the derivative of that with respect to r. So we get dv over dr. And that's going to give us 4 pi r squared. And I'm going to multiply both sides by dr. So dv is 4 pi r squared dr. Okay, so dv is the propagated error in the volume of the ball. So what we want to know is if our measuring device is off by 0.01, 1/100th, how much could our volume be off is basically what this is asking. So all we have to do is plug in. We have 4 pi, our radius is 0.7, and dr, that's delta r, so it's plus or minus 0.01. And when we plug that all in the calculator, we get plus or minus 0.06158 cubic inches. So if our measuring device is off by 1/100th in either direction, that means our volume, the error in our volume, could be off by something like 6/100ths. And as long as that value is within whatever acceptable range, our mechanism is still going to work with that kind of error in volume, then we're okay. So that's just an example from engineering of how we can use differentials.